not likely to run without any problem. Okay, so because this executable was generated with based on that instruction set architecture for that operating system and hardware. So if you take it to another operating system which is totally having all the different instruction set architecture and hardware, it won't run that directly. You have to kind of do some modifications to it. Okay? So the thing is, you don't want to go for a separate machine altogether to just run one program, right? So rather, I would prefer a kind of a virtual machine that I can run on the top of my Windows machine, and the virtual machine runs Mac. Okay? So nowadays you can run a Windows machine, you have a Windows machine as the underlying host machine, and on the top of which you can run multiple virtual machines. And one virtual machine could be a Mac machine, and one could be something else, a Linux machine, and one could be another Windows machine, and so on. Okay? So that's the idea. So what is the motivation for this? So traditionally, again, you cannot run Windows applications on a PowerPC hardware, or similarly, you cannot run a Mac application on an x86 hardware. Okay? So this is limitation from a traditional point of view. But with all the growth in technology, you have what? Plenty of memory and all this quad core, multi-core and all those things. You have a lot of processor availability, right? So you cannot just afford to lose all those things. So for example, in a single machine, you have say 4 cores and you're running only one operating system, and you're not making use of all these cores all the time, because even though you try to parallelize your programs, right, there's still some serial processing involved. So all your cores are not used all the time. Okay? So that's why, again, traditionally people are running servers in each, like network administrators were running what? A file server, web server, database server, all these things on separate machines. So nowadays they don't run all these things on separate machines. They run it on one single machine, each running on a particular port. Alright? So even from an attack point of view, someone can only bring down a particular virtual machine. So if a file server is attacked and it's running as a virtual machine, only that virtual machine will go down. The host machine will not be affected. Okay. So the underlying goal is to maximize resource usage. So that's the basic idea. Okay. So sometimes what we could do is we could really hard code that each virtual machine will use 1 or 2 cores, so that they don't compete for the cores. Okay, so you can really make it like a static allocation. Sometimes you could make it even dynamic allocation. So in the second project, when you really install this Ubuntu virtual machine in Oracle VirtualBox, you would really do all this configuration. Same thing with memory. Because when you run your virtual machine on a host machine, right, the host machine has what? A RAM, memory, and hard disk and all those things, right? So how much of this are you going to use it for the virtual machine? So you could make it dynamic. You could set there's a minimum that you will allocate at least, and then after that, whatever is needed, you will make use of that for your virtual machine. So you don't have to statically allocate like 8 GB of hard disk or whatever you want for the virtual machine. So it could be on an on-demand basis. And the kind of beauty with this virtual machine is